Hey class, I haven't made a video like this in a while, but we are going to try this out. Okay, we're going to work 5 problems together, and I took these from the EOC test that was released. It's the practice one you guys did. Again, I'm going to take problems like this, modify it, and make it into your final. So what we have here is we have 5 problems, numbers 14 and 15. Okay, I just went with what was on the EOC. And then down here we've got number 22, number 23, and then number 9 down here. Okay, just for the sake of formatting, because these 2 questions go with that chart, and these 2 questions go with this chart, I want to make sure it fit it all on there, so number 9 in at the bottom. Okay, anyway, we've got 5 problems here. Let's look at the first 2. All right, using information provided to answer questions 14 and 15. Okay, use the table below. The table below shows the times taken by 2 marathoners running a 26-mile marathon to complete the 4 legs, each 6.5 miles long, of the race. Okay, so each leg here is 6.5 miles long. All right, runner 1 took this long, this long, this long, and this long. Okay, runner 2 took this long, this long, this long, and this long. All right, so we added up his times. We added up his times or hers. All right, and we would get their total time for the marathon. Now you may know that a marathon is normally 26.2 miles. Okay, but in this question, it's a 26-mile race. All right. Okay, the average speed of runner 2. Okay, let's look at question 14. The average speed of runner 2 over the 4th leg of the race was most similar to the average speed of runner 1 over which leg of the race? Okay, 1st, 2nd, 3rd, or 4th. All right, let's look at the average speed of the runner 2 over the 4th leg of the race. Okay, so runner 2, 4th leg would be 45 minutes, right? Now, if we want to know speed is equal to distance divided by time. And we want to compare different times, right? The thing is, in this question, every leg of the race was the same distance, all right? It says each was 6.5 miles long. So really, since the distance is always the same, all we need to really consider is the time. So we're going to look at the time. So which one was closest to 45 minutes? Well, let's see, 36, 36, 38, 32. So number 3, right, the 3rd leg of the race for runner 1 was most similar to the 4th leg of the race for runner 2. Okay, it was closest in time. So without even doing any of this division here, we can figure that out, right, by looking carefully at the problem statement. Okay, so let's see, 3rd leg, so we'll circle that one, right? There's our answer for the first one. And all we had to do is compare. We didn't even have to do any math, okay? Now, if you want to, you could do the distance for the 4th leg here was 6.5 miles divided by 45 minutes. All right, and that would give you so many miles per minute, okay? That would be the speed for that leg of the race. And then we could divide that for all these other ones. But don't spend more time if you don't have to, okay? All right. Secondly, in completing the 26-mile race, runner 1 was faster than runner 2 by a time period closest to. Okay, so they're talking about the entire race, right? The entire 26 miles. All right. Okay, so again, they're talking about the entire 26 miles. Runner 1 was faster than runner 2 by a time period closest to. Well, there's a couple different ways we could do this, okay? One, we could add up his times, right? We could add up runner 2's times, okay, and then subtract the totals. Okay, that's a good way to do it. Another way to do it would be to subtract here each time, okay, and then add up the difference. I'm going to choose to do it the second way. It doesn't matter. Okay, 48 minus 36 is 12 minutes. Okay, 52 minus 36 is 16 minutes. I'm just writing it right here. Okay, 50 minus 38 is 12 minutes. And 45 minus 32 is 13 minutes. All right, now I want to add 12 plus 16 plus 12 plus 13. Okay, that'll give me the total time. So I'll just put a plus and a plus and a plus and equals. Okay, might as well use a handy dandy calculator. 12 plus 16 plus 12 plus 13 equals 53 minutes. Okay, so we know that the time period difference was 53 minutes. Okay, now you'll notice all these are in hours. So let's go ahead and divide that by 60 minutes per hour. right? And we will get 0.883, all right, hours. So which one of these closest to? B. Okay, it's closest to an hour. Certainly a lot more than a half an hour. All right, less than an hour. It's closest to 1 hour. Okay, all right. Let's go down here now and look at this graph. Okay, this graph is used for questions 22 and 23. It shows the speed of an object over a 40-second time period. Okay, here's our time. Here's the speed. It starts at 10 seconds, you'll notice. All right, it goes from 10 to 20, 20, 30, 30, 40, 40, 50. Okay? All right. Over which of the following 10-second windows of the 40-second period do the object's acceleration have the greatest magnitude? Okay. Acceleration is equal to the change in speed over the change in time. Okay? Another way you can say that is you can say do the final velocity minus the initial velocity divided by the time. Okay, so these are speeds. Speed and velocity is essentially synonymous. So take the first velocity, the second velocity, subtract the two, divided by the time. All right, you'll notice here speed is constant, so there's no acceleration. Here speed changes quite a bit, right? And then here speed changes less. Now, since acceleration is equal to the change in speed over change in time, it's pretty easy to recognize that the biggest acceleration happened from 20 seconds to 30 seconds. Okay, so that's going to be V. If you wanted to calculate that, you could do 20 meters per second minus 30 meters per second over the change in time, right, which would be 30 minus 20 is 10 seconds. You'll find out that it's negative 1 meter per second squared. Okay? All right, minus 1 meter per second squared. Okay, that's his acceleration. All right, okay, which of the following calculations gives the object speed at the start of the 40-second period in kilometers per hour? Okay, these are meters per second. We want to find kilometers per hour, so what we have to do is convert meters per second to kilometers per hour. So at the start of the 40-second period, he's going 15 meters per second. All right, so he's doing, wait a minute. Okay, I got confused there for a second because I was thinking at the start of the 40-second to 50-second window. Okay, he's actually talking at the start of the 40-second period. Okay, so we're up here, right? He goes 10 seconds, 20 seconds, 30 seconds, 40 seconds. So look up here at the 30, okay? Not 15. 30 meters per second. Okay, now if you remember our unit conversions, that's really handy. Okay, we need to get rid of our meters and change to kilometers. All right, because we want to get to kilometers, km, per hour. Okay, well, he's traveling 30 meters in 1 second right now. 1,000 meters is 1 kilometer. All right. My meters cancel out, and now I got kilometers over seconds, but I want kilometers per hour. So we're going to do 60 seconds is 1 minute, and 60 minutes is 1 hour. Okay, so my seconds cancel and my minutes cancel. Now I get kilometers over hour. So if I want to know which of these calculations gives me the speed, I got 30 divided by 1,000 times 60 times 60. Okay, you can't see that. 30 divided by 1,000 times 60 times 60. 60 times 60 will be 3,600. Okay, so we got 30 times 3,600 divided by 1,000. Okay, so C right here is perfect. That's our answer. Okay, all right. The last problem, kinetic energy is measured in joules. A joule is equivalent to which of the following units? All right. If you don't know already what a joule is, there's a way to figure that out from the kinetic energy. Okay. Hopefully you remember that kinetic energy is equal to 1/2 times the mass times the velocity squared. Okay. Mass in the SI units is measured in kilograms, so we're going to have 1/2 times some number of kilograms, right, times velocity, which is measured in, you guys don't remember, look up here, meters per second, okay? Meters per second, this quantity is squared, okay? We're only looking at the units, right? We don't care about the actual numbers. We're not given kilograms, we're not given meters per second, right? We're not given a mass or a speed. So the unit is going to be kilograms times meters squared over seconds squared, or this guy right here, okay, A. All right, that one has kilograms squared times meters per second. This one has meters per second squared divided by kilograms, and this one is meters per second divided by kilograms squared. So B, C, and D are obviously wrong, okay? Also, you might remember that all energy is measured in joules, so potential energy equals mass times gravity times height. All right, what happens if we look at these units? Okay, we have mass is measured in kilograms. Gravity is an acceleration, and its units are meters per second squared. And height in the SI units is measured in meters. Okay, so a kilogram times meter divided by second squared is equal to kilograms meters squared per second squared. All right, which is equal to kilograms meters per second quantity squared. All right, so you'll notice this is a joule and that is a joule. Okay, both are joules. All energy is measured in joules. Okay, kilogram meter per second. This whole quantity here, meters per second, is squared. All right, great. Hopefully that helps you out. If you have any questions, I'll be happy to try to answer them. And this lecture has been prepared for those that won't be here today. Okay, if you are here today, you get to watch it and ask questions. If you're not here today, you'll need to watch it and then find me at another time to ask questions. Thanks a lot.